Hi, everyone. This is a re-recording of the Scaling with the REST API session that was unfortunately lost during the recordings of the live session. My name is Kel Markert. I'm a cloud geographer with Google Cloud, and I help support Earth Engine use at Google Cloud. So today we're going to be talking about scaling with the REST API. And what we mean by scaling with the REST API is, Earth Engine allows access to massive compute for geospatial processing, but scaling means here is extending the work with Earth Engine to additional things such as more machine learning opportunities if you have external processing that you need to do, such as hydrologic modeling and what have you. So here we're going to talk through scaling out some of your work through those avenues with the REST API. So who are we? The cloud geography team consists of 5 of us at the moment. So as I mentioned, I'm Kel. We also have Sean Woltman, who's the head of cloud geography, Michael DeWitt, who's a senior DevRel engineer, Brady Allred, and Gene Domkitz. So we all help support Earth Engine in the cloud. And there's other interesting sessions that have been going on with Geo for Good, talking about integrations of Earth Engine with cloud and using Earth Engine in an operational context. And I encourage you to view those sessions as well. All right, so today we're going to go over a brief introduction of the API and what it is and kind of how to use it. We're going to spend the bulk of the time going through a hands-on workshop, going through a Colab notebook, and then we're also going to explore Google Cloud Console to view usage and statistics and see what's going on the back end with the REST API call. And then we're going to wrap up. So brief overview. So the REST API allows access to the Earth Engine data catalog and computation platform through HTTP requests. So it's like any other REST API that you would encounter where you send over a JSON body and hit a particular endpoint, and then you can get back those results. Additionally, you can authenticate with OAuth 2 using your personal or service accounts. So it integrates with local environments or even better in a cloud environment. You can also build custom applications on top of Earth Engine in any language by using the REST API. So currently we support, and I'll talk about this a little bit later, but currently we support the JavaScript and Python client APIs. With the REST API, you can then extend to other languages like Java or Go or something like that. And then with the integrations with cloud, we can now monitor our API usage and quotas. So going a little deeper into how Earth Engine works from an API standpoint. So I mentioned there is a JavaScript and Python client libraries. So those two actually sit on top of the REST API. So when you're coding in either of these client libraries, what they're actually doing is creating the API calls to the REST API, and the REST API then talks to Earth Engine on the backend. So theoretically, these client libraries can be extended to any other language, like I mentioned, Java and Go. So if you have existing services that you want to call Earth Engine through, and it may not integrate well with Python or JavaScript, you can then build out those services internally for your projects. I highlight here that there's this legacy API, so that has been deprecated, and so we're no longer use a legacy API, and again, all of the requests are routed through this REST API. So going a little deeper into what you can actually do with the REST API, so you can do asset management, so you can manage all of your data on Earth Engine platform, creating data, deleting, updating, moving things. You can set permissions for your assets, and then you can also set up computation, so you can compute your values, pixels on either features or images. You can import data, export data, list images of features, get pixels, and I'll talk a little bit the difference between computations and get pixels, create map tiles, and set up long-running operations through batch processing. And there's a link here. So if you want to explore all the different calls that you can make with the REST API, this link provides all the documentation you would need to get started and all of the inputs for all of the calls. So kind of going through and walking through what this actually looks like, right? So this is using Python to make a REST API call. So this is not to be confused with the Python client library. This is just pure Python creating HTTP requests. So if we break this down into what each line or groups of line are actually doing, so this example is querying a data catalog for images. So what we're doing here is we're setting coordinates to query. We're specifying our cloud project ID. So all of the HTTP requests get routed through a cloud project. And so you need to specify what those are. And then we're specifying what the image collection that we want to query is. And then we construct our endpoint using this information, such as the cloud project and asset ID. And then at the end here, you'll see this colon and list operation or list images. List image is the operation that we are using, the function from the REST API that we're using. And then we also provide the request info, so the body of the request, and then we send the request. In this case, it's a GET request, but we can also do posts for other things. Going into another example, right? So that was getting a list of images. And so here, in this case, we are accessing the data catalog assets and getting the data back from the data catalog. So again, walking through what these codes are, what this code is doing. So we're specifying a cloud project ID, the asset ID, and then we're using it to construct an endpoint. I want to point out here that this operation at the end here is get pixels instead of list images. So get pixels will actually give us the data from the images. And then we also have our request info. In this case, it's what's called a pixel grid. So this pixel grid is specified in the documentation. And what this is essentially the affine transform for the area that you want to request. And then you send a request, and then you can read your results as an array using NumPy or whatever other package that you want to use. In this case, Earth Engine, the file format is a NumPy array, so we read it with NumPy. All right, so you may be asking, I love the JavaScript API, I love the Python API, and why do I need to know about the REST API? So the REST API is very useful if you want to, again, integrate with existing services. So if you want to connect Earth Engine computations with your existing infrastructure, maybe you have a web framework built on Java Spark, or you're using some Go libraries. This allows the integrations of Earth Engine into those frameworks that you're already using. The other use case I want to highlight is if you want to pull Earth Engine results to an outside process. So this is something that I've done quite often. My background's in hydrology. I use a lot of hydrology models, but Earth Engine doesn't work well with hydrology models, just the way the computation model works. So what I do a lot is I use Earth Engine to process massive amounts of data, and then I use the REST API to pull data on the fly into hydrologic models and then run those. So that's an example of where that might be helpful. And then the other part, the last one that I want to mention too, is if you want to connect Earth Engine with other cloud services that may not support the Python or JavaScript APIs. So there's a lot of different cloud services available that Earth Engine integrates very well, but the REST API is another connection point that's available for you. Okay, so that was a brief introduction to the REST API, and now we want to go through a hands-on exercise. And so if you're following along in the slides, you can access the notebook by going to this URL down here at the bottom. So we're going to go over there now. Okay, so now we're here at our notebook, and first thing we're going to do is we're going to connect to the Colab runtime. And so if you're not familiar with Colab, it is an ephemeral VM service. And so you have to connect each time if it's been a while since you've connected. So with this notebook, first off, I want to mention that we are going to be making the calls using the Earth Engine API. So if you do not have it enabled for your cloud project, make sure you click here and enable it for your cloud project. The other thing I want to mention is we are going to be storing some data on cloud storage and using this notebook and Earth Engine. So if you want to follow along with that part, what I suggest is you set up a cloud storage bucket so that way we can actually save the data and create the assets there. Okay, so first thing you're going to do, you should be using Earth Engine with a cloud project. And so just make sure you change your project ID here to whatever you are using. This is my cloud project, so I'm just going to keep this here. And then the next thing that we're going to do is we're going to authenticate with Earth Engine. So we're going to go through this auth flow. We're going to be using, we're going to be storing and creating assets. So we want to have write scopes. So leave that unchecked and make sure you have the correct cloud project chosen. So we're going to go through and generate a token. We have to do a couple clicks here. I trust this. And now I have a auth token. So I'm going to copy that, close, and paste here. And now you should see something that says successfully saved authorization token. So now that we have our auth token and we are loading it into this authorized session with Earth Engine, and this authorized session will be a HTTP session, so that way we can make those REST API calls. So we're just going to test our credentials here to make sure we're able to call the REST API. So this is a very simple example where this is our URL endpoint, and we're just going to get the results. And what this is doing is querying the assets and looking at the Landsat folder, and we can see, in fact, that it is a folder. Okay, so hopefully with your credentials, you're able to make the query and get the correct response. Now we want to actually scale our EE process. So the process that we're going to work through here is we are going to compute. Basically, we're going to create a deforestation detector. And this is just for demonstration purposes. I know that there's a lot of data sets on deforestation, but the idea here is that we're going to use Earth Engine to create yearly mosaics for a before and after a year. We're going to pull those results outside of Earth Engine, train a classifier, a logistic regression classifier using scikit-learn, store the data, move to cloud storage, and then have cloud storage be as the backend data store for a Earth Engine image collection. And so we're basically pulling data outside of Earth Engine, doing our process, and then putting it back in Earth Engine. We're just going to do this in a seamless way using the REST API. To do so, we're going to install a few packages. And while this installs too, I just want to mention that this is a fairly simplistic example of what you can do with Earth Engine and machine learning and whatnot. So the idea here is that it's a constrained example and it gets the juices flowing, the creative juices flowing, so that way you can think of more interesting ways that you may use Earth Engine and the REST API. So we're going to import a package here called REST-EE. This is a package that I wrote for my research, working on my PhD and everything. And this is a package that basically helps create those, creates the HTTP endpoints for what you want to do with Earth Engine, and also structures the request bodies. So that way we're not having to deal with a bunch of JSON stuff. So we're going to import this. And then we're going to create a session container. All this is just stores the project ID and the authorized session. So that way we can create those calls. And then we're going to initialize Earth Engine with our Earth Engine session credentials and set our project ID to the project ID. All right, so to begin, we're going to do some server-side operations. And so here we're going to create yearly mosaics of Landsat around Cambodia. So first off, we're going to import the country and select Cambodia. And then we're going to write a few functions to do our pre-processing. So this function here is a cloud masking and QA processing function. We also want to use other information, just not these raw spectral bands. We want to calculate NDVI, modified normalized difference water index, and bare soil index, and then add those bands. Add those bands to the image. The last thing we're going to do here is just create a group those two functions together, so that way it's just one pre-process call. So now we're importing in the Landsat 8 collection, and then we're going to filter bounds by Cambodia. And now we're going to make a before and after composite. So here we're going to focus on 2020 as the year that has experienced deforestation. So we're creating a composite for 2019 and then 2021. And after we create those composites, we are going to add those bands all together. Now, if you're following along at home, you may want to export this image. If you do export this image, you can run this cell block here. It should pull in your project ID and export the image to the correct asset location. And it will be called deforestation demo image. But for the sake of demonstration, I have already exported this, and so I'm going to pull that back in to speed up processing. So now what we're going to do is we're going to calculate our where deforestation happened. So this is going to be our label data. So we're pulling in the Hansen database, the Hansen data set, and pulling in the loss year for 2020. And now what we're going to do is we're going to read in that export image, add the loss band, which is the labels, and do a stratified sample. And we're stratifying by loss. And so when, from a scientific standpoint, deforestation is a relatively small area compared to what's not deforested. So we're making sure that we have equal class bounds between what was lost or deforested versus not. So we're going to go ahead and sample that. Again, this is optional. So this will be an export to where we can export the samples. I'm going to skip that part again. Okay, so that's all of our server side. So we just said, okay, Earth Engine, we want to calculate a before and after. We want to composite. We want to merge those together. And then we're going to pull in loss information, and then we're going to sample where there was loss versus not. So here we're going to pull in some packages to do some request processing using the REST API. So we want to pull in NumPy, and then we're going to pull in some this thread pull executor, so that way we can run the requests concurrently. So first off, we need to specify some information so that way we can get the data in the correct coordinate system. So we're going to specify the UTM zone for Cambodia here, and we are going to get the bounds for Cambodia. These are coordinates. Now we're just going to get min-max bounds. And with the REST API, like I mentioned, when we're requesting the data, we need to specify what's called this pixel grid. And so that is essentially the affine transformation to where we are specifying a bounds and how many pixels we want to request. So we're going to set these up manually, and basically, and because Cambodia is a fairly large country, what we're going to do is we're going to chunk this out into little tiles. So that way we're requesting Earth Engine to process concurrently in smaller tiles, and we are going to get those all using multiple concurrent requests. So here we're going to specify the number of tiles in X and Y, and then we're using the REST-DE package here to specify the domain. So this is the area that we want to request. And so you'll see here, we're just looping over and just making tile locations to request. Okay, and so now we're going to run our requests. And so this is going to take a little while to process. Okay, so now we see that the process is done. You'll get a few errors. It's just saying that the thread pools are kind of working together. Yeah, so I want to mention here that we're using a max workers of 20. So what that means is it's running 20 concurrent processes on the back end. Realistically, Earth Engine can handle more. And so you want to access what's called this high volume API endpoint. And so the high volume API endpoint allows for higher concurrent processes, more queries per second. And that allows you to fully leverage the full capabilities of Earth Engine, doing something like this with the REST API. And this will integrate nicely with other services like Dataflow on Google Cloud Platform, which can be used to manage a lot of parallel processing. So if you have something that you want to run in parallel, a process, you can use Dataflow and the high volume API, and it should be able to handle a couple thousand pretty nicely. Okay, so moving on, now we have all of our data. So now we're just going to inspect it. So what the REST-EE package is doing is loading the data in a xArray object. So what we can see here is we have coordinates. We have our X and Y coordinates. We have our data variables, which are all the bands. And if we expand this, it actually has data as the array. So xArray is a really nice container to handle geospatial data and multi-dimensional arrays. Just to visualize, we're going to get a random block from the data set, and we're just going to visualize it here. And so now we can see that this is NDVI, where higher green areas is higher NDVI, so forest, versus lower NDVI, which could be indicative of water or bare earth or cities or whatnot. No vegetation. Okay. So now that we have the images that we want to run it on, we're going to get our samples that we are going to use to train the classifier. So here we can also request our features to a geodata frame. So this is using GeoPandas on the back end. It's requesting a feature collection as a GeoPandas data frame. And so we can see here that these are all of our samples where we have all the features that we want to use to classify. It has our loss, which is the label, and then a geometry information. So here we're just going to plot the samples that we're using, so that way we can see just the spatial arrangement of the samples that we'll use for the classifier. And here you can see that the green areas are no deforestation, and the pink areas are where there was deforestation. So now that we have all of our data locally, we can now begin processing our classifier. So we're just going to import in scikit-learn. Here we're using the REST API to get the values, which would be the band names for the whole stack. This is just to demonstrate that REST API is not only useful for getting data from images or features, but you can also get values from something, whether it's a computed list or array or something. And so now we are going to split this up. So this is local processing. This is very similar to any kind of local Python machine learning process where we're getting our X, which are features, Y, which is a label. We're going to do a train and test split. We're going to get our classifier and fit. We're going to predict and then test. So with our test data set, we see that it's 83% accurate, which is fairly good for a quick example like this. And so at this point, if you want to use it for other things, you may want to save your classifier and then load it in later. But here we're just going to continue on. And now we're going to run the predictions on each block. So what this cell is doing is it's looping through each block or tile of data, of the image data that we have. It's running the inference using the classifier, and then it's just appending them all together into a list. So at the end, we'll have a list of image tiles that have been predicted on where's deforestation. And so if we look back at our example from earlier that we plotted, here we can see the results from the classifier. The classifier is actually a fairly good classifier for forest area. So anywhere in the middle here with the green, it's actually forest. But the yellow areas are where it's predicting that there is deforestation. So you can see on the fringes here of this forest that there's a little bit of deforestation happening. Okay, the last thing that we're going to do is we're going to save the data as cloud optimized geotiffs. So remember I mentioned in the beginning, we said that we wanted to pull the data outside of Earth Engine, do some local processing, and then put it back in Earth Engine. We're going to save our results as cloud optimized geotiffs, store them on cloud storage, and then have Earth Engine point to that data on cloud storage. So that way we can use it with the Earth Engine later. Here we're importing in packages to do some local processing. RIO Xarray is a really good Xarray extension for raster data. We're going to create a a folder for staging our data, and then we're going to run this process for saving the data. This is going to take a little bit to process, but I want to walk through what's going on here. Basically, we're creating a function to save the cloud optimized geotiff. We're using the raster IO extension for Xarray to basically save some geospatial information and then write it as a cog. And you see here the driver is a cog. And then what we're doing, we're using thread pull executor again to run these things in parallel. Another thing that I want to mention while this is processing is that, you'll notice that what we've been doing is we loaded everything into memory, right? And so when we're processing these things, if you're using Earth Engine at a large scale, you may want to do this process as one pipeline for a tile or something, right? To where this whole thing would be like one function, and then you can run these functions in parallel. So that way we're not having to load the whole data set into memory. You can just process one by one, which would be a little bit more memory efficient and more easily parallelized across multiple cores. So I just want to note that, but for demonstration purposes, we did everything kind of locally. We're going to wait for this to process, and then we'll pick back up once it's done. Okay, so now we see that this cog write process has finished. And so if we go here to our files and look under staging, we can see that we have our deforestation prediction blocks written out. So I'm going to close this again. Okay, so cogs have a very cloud optimized geotiffs or cogs have a very specific file format that needs to be adhered to make sure it's valid. So we're actually going to use this raster IO extension to validate the cog to make sure they were written right or correctly. I like to check and double check my work. So this may not be useful in a production environment, but if I'm testing something, this is very useful for me. And I just want to note too that the raster IO extension, this cog.io process, that just checks whether the structure is right. You also, for Earth Engine, need to make sure that the projection information is written correctly, and you can use GDAL info for that as well. Okay, so now that we have the data written on locally in this notebook, we want to move the data over to cloud storage. That way we can create a Earth Engine image asset. So to do so, we're going to have to log in with gcloud. Unfortunately, our credentials for Earth Engine don't translate over to gcloud, so we're just doing a login here. So I'm going to go through the login process, click yes, I allow. I have my token, and I'm going to close this. and then paste my token here. Okay, so now I'm logged in. And so here's where you want to set up your cloud storage bucket. So we have set up our cloud storage bucket earlier in the notebook. Here's where you paste the bucket name that you want to save your data to. So mine is called cog demo. I just change it to whatever yours is. And then we're going to use this gsutil to copy the data over to our cloud storage bucket. So we see that this is all writing, should be fairly quickly. And we're done. Okay. So now that all our data is sitting on cloud storage, the next thing that we're going to do is create this cog-backed asset. And so what we're going to do here is we're going to create a new collection. So I'm going to create a collection called demo cog collection. Again, you can change it to whatever you'd like. And then it's going to create the correct asset ID on Earth Engine side. Because remember, you're using cloud project, so it should be projects, your project ID, assets, and then create this collection. So we're just going to go ahead and create that collection if it does not exist already. And then this is the code that we're going to be using to create the cog-backed assets. And so this is the endpoint that we'll be sending the request to. And what it will be doing is we're just going to loop through all of the file names that we have on cloud storage and say, create a cog-backed asset. And so what this is doing on the back end is the data actually sits in cloud storage, but then Earth Engine says, okay, I know where this sits on cloud storage. I have the geospatial information, metadata information. And so whenever I want to use it with Earth Engine, it just pulls from cloud storage. So we'll let this run a bit and it should be done here soon. Okay, so now that our requests to create the cogs are finished here, I do want to mention that when you send your request, you can actually specify properties and metadata associated with each image. So you can change this to like what the source is or version of your model or process, and you can specify start time, end time, a lot of the associated metadata, which is good practice. So at the end here, this is just what the response looks like, that it was created the image asset. And so this is just saying we're all good. So now that, again, looking back at our journey, what we did is we used Earth Engine to create before and after mosaics for deforestation. We sampled those areas for deforestation. We pulled the images and those samples outside of Earth Engine to our local process, local machine, did some machine learning workflow, saved the results, and we are pointing Earth Engine to those results. And so now, just to visualize, we're going to go through and do some visualization. We are using a new experimental package that was developed to make visualization and working in a Jupyter environment easier. This was demoed in the Python 101 and Python 102 sessions. So if you want to learn more about this Earth Engine Jupyter package, I suggest you watch those sessions. So now our package is installed. So we're just going to import. And here we're going to, this is pulling in the prediction images. So we're going to mosaic them all together since they're different tiles. We're going to determine what's deforestation, in this case, anything over than 75%, and do some water masking. And then we're going to pull in our mosaics. And this is some parameters for the map. And then we're specifying our layers for the map. And then we're going to inspect. So here's our results. And so I just want to click around for a bit. So if we look at this area here, which is showing up pretty brightly, so the orange areas are deforestation. If we click the before and after, we can see that, you know, there was in fact a good amount of deforestation that's happening on here. And if we toggle on and off where we're predicting that the deforestation occurred, it is in fact happening. And so if we click on here, oops, There we go. We should be able to see what the pixel values are, and then we can see that it has a probability of 87% probability of deforestation. And so we tag that as, yes, in fact, it's deforestation. And so just zooming out, we can see that, this is a large area. And so we can zoom around and explore what's going on. Okay, so this concludes our hands-on demonstration for the REST API. I hope you found it beneficial, and you can then go off and do some fun, exciting things for your workflows with the REST API. So now we're going to go back to the slides. Okay, so moving on with the slides, the last thing that we wanted to talk about from the REST API perspective is looking at Cloud Console and looking at monitoring our usage and stuff. So here we're going to just basically walk through looking at our Cloud Console. So I'm going to go out of the slides here. And if you go to this link here, it should redirect you to this API monitoring page for our documentation. And so if you go and read through the documentation, you should have information on how to monitor and even tag your workloads for using different processing. So I'm just going to go to my Cloud Console just to show what's going on. I have monitoring pinned, but you may need to go to your, scroll down under more products and find monitoring. But if you find your monitoring, we're going to go here to Metrics Explorer. And this is where we can select a metric and actually go in and look at information and see what we're consuming. So if I type in Earth Engine under select a metric, Earth Engine, or just Earth, you click here and see that we have two metrics. We have project metrics. And these metrics, it'll say used bytes. So this is storage on Earth Engine side. So if you are storing data within your cloud project, it'll have used bytes. And then we have used EECUs. So I'm going to click on used EECUs and apply. And you can see here that now we have a little graph. And then what you can do is you can group by different compute types or client type. So whether it's using Python API or the REST API. So let's do compute type first. We're going to look at some. And so here we have online usage. You can see what that usage is for different times, and they will tell you how much EECUs that you're doing. And this is CPUs over second. So this is 166 EECUs per second. And so we typically monitor by EECU hours. So just be aware of this y-axis here. And if you want to group by client type, this can show, here we have usage by the Python API versus other APIs and whatnot. So this is a nice way to visualize what's going on. So that way you can monitor all of your different projects that are going on. Okay, going back here to our slides. So the next steps, I encourage you to explore the Earth Engine REST API documentation. This provides in much more detail than we can go into an hour of, what all of the operations for the REST API are doing, all the parameters as inputs, and things like that. And we also want to hear your feedback. So what do you envision using REST API for? Whether that's, again, integrating with existing systems, a specific process that you're interested in. Do you have any experiences or requests that you want from the REST API that, things that you want to see that you're able to do? Please let us know. And I do want to mention too that, this REST API session is part of a sequence of Earth Engine and cloud sessions. So Brady Allred had a Earth Engine and Cloud session I encourage you to watch. But also, there's two other sessions, such as scaling your work and impact and using Earth Engine operational context, that I suggest you looking into and exploring to give more information on how you can use Earth Engine in cloud. So with that, I appreciate your time and hope you enjoyed the session.